I step into darkness. A silent cloak drapes the world. And yet, light seeps through. Walls dissolve. Reality leaks. Your eyes tell you, solid barrier, final limit. But today, 2025, the Nobel has just upended that intuition. Scientists have proved that reality itself can tunnel right through what you believed impenetrable. That what your senses insist is fixed and rigid may be nothing but a veil. This is not fiction. It is the headline. The 2025 Nobel Prize in Physics was awarded for the discovery of macroscopic quantum mechanical tunneling and energy quantization in an electric circuit. When we say tunneling, we usually speak of electrons, or photons, or particles darting through barriers they shouldn't. But the genius of this new work? It scaled that weirdness up. They made a circuit, a macroscopic object you could hold in your hand, behave like a single quantum particle, and they forced it through an obstacle. They made reality leap. What if every object, walls, your body, the limits you perceive, were not hard boundaries but probabilistic thresholds? What if beneath the skin of reality, there's a possibility it slides, shifts, escapes? Today, I will walk you into that possibility. We'll travel through experiments, paradoxes, philosophy, and futures. By the end, you might see your world as permeable. Let me take you behind the curtain. How does one make something macroscopic tunnel? How do you force reality to defy its own constraints? First, the concept of quantum tunneling. In the quantum world, a particle doesn't need to go over a barrier. It can probabilistically appear on the other side, even when classical energy forbids it. Think of an electron trapped by walls of energy. It borrows a chance, appears on the far side, then seems to pay back that impossibility. In atoms, this underlies radioactive decay, the operation of transistors, and countless other quantum phenomena. But quantum tunneling traditionally works only on atomic, tiny scales. When many particles are involved, classical behavior dominates. A baseball doesn't tunnel, a brick doesn't leak. The energy fluctuations among electrons cancel statistically and blur the quantum weirdness. Enter superconductors, and in particular a device called a Josephson junction. That's a sandwich. Two superconducting regions, separated by a thin insulating barrier. Superconductors are special. They allow electrons to flow without resistance, and the electrons move in unison, forming a coherent quantum state. This coherence is key. In a Josephson junction, in the right conditions, electrons or electron pairs may tunnel across that thin barrier as a collective quantum state, maintaining coherence across macroscopic distance. This effect was predicted and partially explored decades ago, Josephson effect. The trio awarded the 2025 Nobel, John Clark, Michel Devoret, and John M. Martinis, refined that idea. They built circuits in which the entire superconducting current behaves as a single quantum object that can occupy discrete energy levels and escape from one stable state to another by tunneling through an energy barrier, even though classically it should be confined. Here's how. The circuit is biased, so it sits in a zero voltage state. No voltage appears across it. That is the trapped, stable state. But underlying that is a potential barrier in energy space. If the quantum state tunnels through that barrier, it slips into a different state, the voltage state, which is measurable. That transition is detected. They could measure when the switch happened and confirm it matches the probabilities and signatures of quantum tunneling. They also showed that energy absorption in that circuit is quantized. The circuit can absorb microwaves only in discrete steps, not continuously. That's like electrons and atoms only absorbing photons in fixed quanta. Here, the entire circuit does so. This is not quantum effect on many electrons behaving individually. It's many electrons locked together, acting as one quantum system, tunneling as a whole. It's the jump from microscopic to macroscopic quantum. And that's the shock. Reality, on scales we can touch, is not exempt from quantum oddity. Now here's the twist. One particular measurement almost broke the very logic of physics. In some runs, the tunneling time appeared independent of barrier thickness, implying bizarrely potential superluminal speeds. That paradox nearly forced physicists to re-examine ideas of causality, time, and the meaning of speed in tunneling. If time doesn't scale with distance, what does that imply for reality's architecture? Next, I'll show you 4 stepping stones of evidence, past experiments, analogies, paradoxes, modern data, that scaffold this discovery. and how each one cracks an assumption you thought untouchable. They told us the quantum world and our everyday world were separate realms. The microscopic was supposed to stay down there, behind the glass of the laboratory, too delicate to touch our lives. But this Nobel proved that boundary doesn't exist. The wall between quantum and real can be tunneled through too. Here's the illusion that just broke. We used to think classical reality emerges from quantum rules the way a picture emerges from pixels. Stable, continuous, unshakable once large enough. But what if that's not true? What if the classical world is just quantum behavior pretending to be normal until the right conditions peel the disguise away? Superconducting circuits are that disguise removed. In those cooled down, vibrationless environments, the noise of temperature dies and coherence reigns. The result? The entire circuit, containing billions of electrons, acts as one entity. You're not looking at many parts anymore. You're staring at a single wave function, a macroscopic wave function. Reality as one body of probability. Think of it this way. In that lab, they didn't watch one particle tunnel. They watched reality itself tunnel. Because when everything in that system acts as one quantum state, the entire configuration of what exists passes through an energetic barrier and reappears elsewhere. No classical trajectory, no continuous movement, just an update, as if the universe blinked, and when it opened its eyes, the configuration had changed. This defies how we define motion, continuity, and causation. If nothing actually travels through the barrier, but the state simply changes, what does that mean for how we experience time? Are we watching a movie frame by frame, or are the frames being rewritten behind our backs? Now here's the unsettling part. This effect isn't an anomaly. It might be the truest behavior of everything, just usually hidden by noise and heat. Every atom in your body obeys the same equations. You don't see tunneling only because decoherence, the interaction with the messy environment, kills the coherence before it can unfold. But at the foundations, the same mathematics holds. So if this tunneling can scale from electron to circuit, could it someday scale to us? Could macroscopic quantum states, human-scale coherence, or even reality-wide superpositions be possible, not in imagination but as physics? And if so, what happens to individuality, to persistence, to cause and effect, when the universe itself can appear on the other side of its own wall? Because the next evidence ladder doesn't just prove the effect. It exposes how 4 milestones in quantum history were already hinting this day would come. And one of them, from a forgotten 1980s experiment, might be the smoking gun we ignored. Science doesn't leap in chaos. It climbs, one paradox at a time. And the 2025 Nobel didn't just emerge from nowhere. It's the latest rung in a hidden ladder humanity's been building for a century, one that's quietly teaching us that solidity, locality, and realness are temporary illusions. Step 1. The Quantum Tunnel, 1928. George Gamow's early tunneling model explained how particles could escape atomic nuclei, even when they didn't have enough energy to climb the barrier. This single idea cracked open nuclear physics. Without tunneling, stars wouldn't shine, and radioactive decay wouldn't exist. Reality already had holes. Step 2. The Josephson Effect, 1962. Brian Josephson predicted that in superconductors, pairs of electrons could tunnel collectively through an insulator, creating a measurable current without any voltage. It was the first whisper of macroscopic quantum behavior. Josephson was mocked, until experiments proved him right, and he later won the 1973 Nobel. That was the first tremor. Step 3. Quantum coherence at human scales, 1980s, 1990s. Researchers began trapping ions and photons in cavities, keeping them coherent for longer and longer periods. A forgotten experiment in 1981 by Anthony Leggett's group measured quantum tunneling in macroscopic systems, metallic rings containing billions of particles. The data showed unmistakable tunneling signatures, but skeptics dismissed it as thermal noise. In hindsight, that was the first macroscopic leak in the wall of reality, the day the classical world quietly cracked. Step 4. Quantum circuits as artificial atoms, 2000s, 2020s. Superconducting circuits evolved into qubits, controllable quantum units used in quantum computers. They could exist in superpositions of currents flowing clockwise and counterclockwise. Companies like Google and IBM turned them into processors. And here's the kicker. Those same qubits are Josephson junctions, the exact devices that now earned the 2025 Nobel. Across a century, Physics was whispering the same truth louder and louder. Quantum behavior never stops at the atomic scale. It's universal. It's just waiting for quiet conditions to show itself. Now, with the Nobel confirmation, the whispers turned into thunder. The 2025 laureates didn't just observe a quantum circuit. They measured reality itself escaping its classical cage. And that long-ignored 1980s data suddenly fits perfectly. The tunneling wasn't noise. It was the universe breathing. So, what does that mean for us? If matter can collectively jump barriers, if space and time themselves permit shortcuts, what happens when we turn this discovery inward, to perception, to consciousness, to causality? Because one of the laureates, in an interview right after the announcement, said something strange. If tunneling scales, then boundaries might not be as real as we think, not even between mind and matter. And that sentence might be the doorway to everything that comes next. When a Nobel physicist says boundaries might not be real, the world should pause, because that's not just a comment about circuits, that's a challenge to our deepest metaphysics. We've always built our comfort on separation, inside and outside, cause and effect, past and future, self and other. Those borders hold our sanity together. But tunneling, in its purest form, says none of those barriers are absolute. It says the universe is not a fortress of walls, but a field of probabilities, where what's here and what's there are just dominant patterns in the same invisible wave. If macroscopic quantum tunneling exists, even for a fraction of a second, then everything you call solid, the desk, the planet, even your identity, rests on conditions that can blur, merge, or leak. Not metaphorically, physically. That idea terrifies classical thinkers, because it means determinism is not a given, and the boundaries we rely on are emergent, fragile, temporary. Philosophers have long debated this, but now, physics is giving it form. Take causality. If tunneling time can appear independent of distance, then before and after might not always obey linear logic. Events could correlate across space-time in ways we can't yet map. We may be seeing hints of a reality that doesn't evolve in steps, but rather updates holistically, the way a quantum wave collapses all at once. Take identity. If many particles can act as one quantum entity, then individuality might just be an artifact of decoherence, a side effect of noise. The self could be a classical shadow of a fundamentally entangled whole. The border between you and everything else might be probabilistic, not absolute. Even consciousness enters the question, not in the pseudoscientific sense, but because the observer effect has always linked observation to quantum collapse. If the act of measurement changes the state of the system, then what happens when we are part of that system? If reality can tunnel through barriers, can awareness? Critics warn of quantum mysticism, and rightly so. Physics is not philosophy's toy. But neither can philosophy ignore physics when physics erases the lines philosophy was built on. Because now, for the first time, a Nobel committee has essentially said, the wall between classical and quantum doesn't exist, which means every limit we once trusted might be negotiable. Every definition of real might depend on context. And that brings us to a chilling question. If barriers are illusions, can they be engineered away? Can we build technologies that force reality to tunnel, not just particles, but processes, signals, even information? Because the 2025 Nobel discovery is already echoing in quantum computing labs, and the next generation of scientists are whispering about something extraordinary, macroscopic teleportation. When the Nobel announcement hit, most people saw a headline about superconductors, but inside physics labs, something else stirred. A quiet realization that this wasn't just about tunneling, it was about controllability. Because for the first time, scientists didn't just observe macroscopic tunneling. They triggered it. They tuned the energy landscape, adjusted the microwave frequencies, and literally made reality jump on command. That changes everything. Start with quantum computing. Every qubit is a delicate quantum system that collapses easily when disturbed. But the circuits honored by the 2025 Nobel are far more stable. Their coherence lasts longer, their states are easier to manipulate, and their tunneling can be tuned to switch between logic levels, effectively functioning as ultra-fast, ultra-coherent quantum bits. Imagine processors that compute not through step-by-step logic, but through controlled quantum leaps, computation by tunneling, then communication. If tunneling time can appear independent of distance, the very anomaly these Nobel experiments revived, then the foundations of information theory shake. Physicists are careful here. Nothing proven violates relativity yet. But some interpretations suggest we could exploit non-local correlations created during macroscopic tunneling events to transmit quantum states more robustly, even over imperfect channels. No faster-than-light messaging, but vastly more resilient quantum networks. A web where data itself can leak through noise barriers the way electrons leak through walls. Next comes energy. Tunneling allows escape from confinement without climbing the full barrier, meaning new low-energy mechanisms for switching states. Superconducting logic could operate with practically zero dissipation, computers that never overheat, devices that defy the current trade-off between power and stability. But there's a deeper horizon, because if macroscopic tunneling is real, if reality itself can perform these jumps, what stops us from engineering larger and larger coherent systems? Google's quantum AI division already runs experiments using clusters of superconducting qubits entangled across chips. Now imagine those clusters acting as one macroscopic quantum state, capable of tunneling not just between energy wells, but between informational configurations. That's teleportation at a new level. Not of matter, but of reality states. We could someday create phase shift devices that flip a system's entire configuration without moving its components. Teleportation without transport. A reboot of existence within its own coordinates. And it won't stop there. Physicists like John Martinis have already hinted that these phenomena might merge with quantum error correction, effectively allowing a physical system to tunnel from a corrupted state back to a coherent one. Reality healing itself by quantum leap. It sounds like science fiction, but every technology that once looked supernatural, from lasers to superconductors, began exactly this way, as a Nobel experiment that rewrote what we thought impossible meant. Now imagine extending that principle to you, to environments, to the biological world. Quantum biologists are already testing tunneling and photosynthesis and enzyme reactions. The line between engineered and living coherence is blurring. Could we someday design life forms that use tunneling for energy or perception? Could evolution itself learn to tunnel through constraints instead of slowly adapting around them? We're standing at the edge of that idea. And the next paper, already under review, claims something staggering: a collective biological system showing sustained macroscopic quantum tunneling at room temperature. If that claim holds, the Nobel of 2025 might only be the opening act. When I first read the Nobel citation for the discovery of macroscopic quantum mechanical tunneling and energy quantization in an electric circuit, I didn't feel awe. I felt unease. Because suddenly, everything I believed about stability started to waver. If even circuits built by human hands can tunnel through their own energy barriers, what about the barriers in us? The ones between intention and action, between past and future, between thought and the world that receives it. We love believing in solidity. The table stays still. The laws of cause and effect behave. You make a decision, and the universe follows. But the Nobel of 2025 whispers something subtler. Maybe solidity is a convenient story, not a fundamental truth. Maybe reality doesn't follow, it flickers, and that flicker has consequences. On the personal scale, it suggests that what you perceive as continuity, your memories, your sense of a linear life, may be a kind of quantum smoothing, an averaged wave of probabilities collapsing just right, moment to moment. You don't notice the tunneling because consciousness edits the jump into a story. On the societal scale, it asks whether our systems, political, digital, ecological, are built on assumptions that reality itself doesn't share. We construct walls of nation, of logic, of identity. But tunneling says, walls are suggestions. They hold only as long as coherence fails to leak. Maybe that's why revolutions, inventions, paradigm shifts always feel sudden, as if something impossible simply appeared on the other side. History, too, tunnels. And emotionally, that's both terrifying and liberating. Terrifying, because it means there's no ultimate ground. Liberating, because it means the impossible isn't sealed off. The same rules that let a circuit state pass through a barrier could underlie creativity, innovation, even transformation. Reality's permeability could be our greatest gift. Imagine living not as an observer of fixed matter, but as a participant in a fluid possibility field. Every decision, every perception subtly shifts which version of the world becomes real. That's not fantasy. It's consistent with the mathematics of superposition. You already navigate probability space. You just call it life. This Nobel didn't just reveal new physics. It reminded us that the boundary between mind and matter, observer and observed, is porous. Maybe consciousness and reality are two sides of the same tunneling event, constantly exchanging information, constantly updating, constantly becoming. So what does it mean to live in a world that tunnels? It means nothing is final. The wall between what is and what could be isn't solid anymore. It's thin, shimmering, waiting for the right resonance, and that resonance might be you. Because next, we'll close the loop, not with data, but with meaning. When the universe shows it can slip through its own walls, what should humanity do with that knowledge? Maybe the scariest thing about the 2025 Nobel isn't what it proved, but what it exposed about us. We crave boundaries. We crave the comfort of believing that walls, physical, mental, emotional, are real and permanent. But the universe just whispered otherwise. It showed us that barriers, no matter how solid they appear, can tremble under the weight of possibility. Reality can tunnel. And that means we can too. Not by violating physics, but by finally understanding it. Every wall humanity has ever faced, the wall of ignorance, of distance, of limitation, has eventually yielded, not through brute force, but through insight, through quantum leaps of understanding, through moments when thought itself tunneled through convention and emerged somewhere entirely new. That's what this Nobel really celebrates. Not a laboratory trick, not an obscure effect, but a principle of existence itself, that nothing fundamental is stuck. The universe is dynamic, adaptive, perpetually reconfiguring itself at the edge of probability. Think of that. If electrons, atoms, and circuits can leap across impossibilities, what's stopping ideas from doing the same? What if our collective consciousness operates by the same rules? Coherence, resonance, transition. Maybe the boundaries between you and the future you imagine are thinner than they seem. Maybe reality isn't waiting to be discovered. It's waiting to be tunneled into. So tonight, when you look around your room, remember, those walls aren't as solid as they look. Beneath them hums a field of potential, vibrating just shy of realization. And somewhere within it, your next leap, your next impossible, is already forming. The 2025 Nobel Prize didn't just reward an experiment, it handed us a mirror. It said, "Look again. The limits you see are only probabilities." Now the question is, what will you do with that knowledge? Do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind.